Hey guys, for this lesson we're going to be learning about a special kind of triangle, and it's a right triangle called the 30, 60, 90 triangle. Now this is pretty self-explanatory, but it's called 30, 60, 90 because this angle's 30, this angle's 60, and this angle's 90. So what we're going to be doing with this triangle is solving for the missing sides. Now we're pretty good about solving for sides if we know what two of the sides are, because then we can just use the Pythagorean theorem. However, the 30, 60, 90 triangle, we're going to try to solve for the missing sides when we only know one of the sides. So let's say the short side is some number. Let's call it 5. Alright, that's just a random number I'm picking. We're going to try and find the other two sides of this triangle without using the Pythagorean theorem. So essentially this is going to be a shortcut. Now, since we don't know much about this triangle other than one side is 5, I'm going to do something that might look a little strange to you. I'm going to double this triangle. So what I've done is I've created the same exact triangle flipped on the other side. And as you look at this, what kind of triangle is this big triangle that we learned from last quarter? Hopefully you said equilateral or equiangular, meaning all three of the angles are 60 degrees, which also means all three of the sides are going to be the same length. So if this small side is 5, this small side is 5, which means this side is going to be these two added together, which is 10, which means this side is also 10. Good so far? Now I'm going to erase that extra triangle, and we'll be back to the original triangle, but now we have one additional piece of information, namely that this side is 10, or exactly 2 times bigger than this side. Okay? Our next step now is to find this missing side here. Alright, and before I show you the shortcut, let's do it the old way from lesson 2 of this chapter. So we're going to label our sides A, B, and C, and set up our equation of a squared plus b squared equals c squared. This gives us 5 squared plus b squared equals 10 squared, which is 25 plus b squared plus 100. So b squared equals 75, and then if we square root both sides, we should get b equals the square root of 75. So b equals the square root of 75, and you might already see where this is going with the radical. We can simplify this. So you'll make your factor tree and get 25 and 25 and 3, and 5 and 5. And you will find that b equals 5 square roots of 3. Therefore, the missing side is 5 square roots of 3, and we have all three of our triangles. However, we did have to use the Pythagorean theorem. So let's generalize this, or make it easier. So remember when I chose 5 as the short side? I just randomly picked that number. So let's say we picked x here instead of 5. What would that turn the hypotenuse into? If you guessed 2 times x, you are correct. The hypotenuse is exactly 2 times longer than the short side. Using that same method, what does that make the medium length side here? Remember, in our previous example it was 5 square roots of 3. But since we replace 5 with x, in this example it will be x times the square root of 3. I drew it out a little nicer for you here, and I recommend you pause this video and screenshot it, because this is a really important piece of notes. What we're going to do is we're going to try and practice one quick example, and I'm going to show you how you use this. So I'm going to move this triangle over off to the side so we have something to reference, and we are going to practice on this triangle. So take a look and notice that this is also a 30, 60, 90 triangle, and the short side is 7. Now, as we just learned, if we want to find the long side without using the Pythagorean theorem, we know that the long side is just 2 times bigger than the short side. So here the short side is x, here it's 7. We take it times 2 to get the hypotenuse. We take 7 times 2, and the hypotenuse in this example is just 14. Pretty easy, yeah? Alright, let's find the medium side here. Alright, so the medium side, it looks like we just take x times the square root of 3 here. So likewise, here we take 7 times the square root of 3, and that is our medium side. This cannot be simplified, so your three sides are 7, 7 square roots of 3, and 14. Alright, here's another one we're going to try together. Notice that this is also a 30, 60, 90 triangle, except I flipped it on its side to make it a little more challenging. And take note that the side that I give you this time is the hypotenuse. Alright, that compares to the 2x here. So the first side we're going to want to find is the short side of our yellow triangle here. So notice if you look over here, to get from the hypotenuse to the short side, it looks like we'd have to divide by 2. So likewise, to get from the hypotenuse to the short side, let's just divide by 2. So the hypotenuse is 24. The short side is half of that, which is 12. Alright, so we have two sides done already. So of course you could do the Pythagorean theorem now, but I'm going to save you some time. And take note on the right-hand side here, to get, if we know the short side, to get the medium side from here to here, we multiply by the square root of 3. So since we know on the left-hand side that this is 12, to get the medium side, we just multiply 12 by the square root of 3. This also cannot be simplified, so this side is 12 square roots of 3, and you have your three sides, just like that. Fairly simple. If you guys are ready to move on, we're going to do one more, a little bit more tricky. Alright, take a look at this purple triangle. As you notice, I flipped it back up to make it a little simpler because this is a challenging problem. So in this one, I have given you the medium side, and you always want to go and find the short side. Alright, so we're trying to get from here and use that to figure this one out. So if we take a look over on the right-hand side, how do we get from here to here? How would you get from x, square roots of 3, down to x? Hopefully you're thinking we just divide both of them by the square root of 3. Alright, so likewise over here, we're going to have to divide this by the square root of 3, making the short side 10 over the square root of 3. Alright, now I know what you're thinking right now. Mr. Olson, we cannot have square root of 3 on the bottom, and you are exactly right. So let's fix this. Alright, if you remember from section 1, to fix this thing, we have to multiply by 1, which is actually the square root of 3 over the square root of 3. Alright, so the top is going to be 10 square roots of 3, and the bottom will just be 3. Alright, and all that work tells us that that short side is 10 square roots of 3 over 3. Oof, a lot of work, yeah? Now, we definitely do not want to use the Pythagorean theorem here. So, let's take a look and figure out how we get from the short side up to the hypotenuse. So remember on the right, we took x times 2 to get the hypotenuse. So, on the left, we're going to take this whole short side times 2, and that should give us the hypotenuse. So some quick math, we have 10 square roots of 3 all over 3, and we are multiplying by 2. Now be careful here, because this 2 is technically on top, right? It's 2 over 1. So we can't combine the 2 and the 3, because 1's a radical, and 2 is not a radical. Alright, but we can combine the 10 and the 2, because they're both integers. So we will get 10 times 2 is 20. The square root of 3 is still there, and there's still a 3 on the bottom. So the three sides in simplest form of this triangle are 10, 10 square roots of 3 over 3, and 20 square roots of 3 over 3. Now you guys, this is a level 4 type problem, so be careful as you're going about these. This is all you need to know. Let me know if you have any additional questions, and you can get rolling practicing. Good luck.